Hello class, welcome to the STAT 215 Lecture 22 video. In this video, we are going to focus on learning how to conduct a hypothesis test for the population mean mu. First, let's talk about what is a hypothesis test. A hypothesis test is a standard procedure for testing a claim about a population parameter. In the next several lectures, we're going to learn about different types of hypothesis tests. We'll learn about one specific type today, but all hypothesis testing is going to follow these 4 steps. Step 1, state the hypothesis. We learned about this in our previous lecture when we learned about the two-line hypothesis where we had our null and alternative. Step 2, specify the model and check the assumptions. If you recall, when we talked about the proportion parameter, also known as the population proportion, we talked about having the assumption of NP hat and NQ hat being greater than or equal to 5. That's an example of an assumption. Step 3, we need to calculate the test statistic and p-value. And step 4, make a statistical decision and state your conclusion in the context of the problem. Step 4 is extremely important, and you've already had some experience to it already. When it says make a statistical decision, that means we are going to reject or fail to reject our null hypothesis. And when we state our conclusion in the context of the problem, we're just giving an interpretation. So let's start looking at the hypothesis test for one population mean. You may recall that our parameter of interest in this case will be mu. We will be asking ourselves, do we have sufficient evidence to conclude that the population mean mu is one of 3 possibilities: less than a specified value, greater than a specified value, or different from a specified value. These 3 options will form the basis of our alternative hypothesis. Then we'll have evidence that is based on our sample size, meaning our sample mean, x bar, and either our population standard deviation sigma or our sample standard deviation s. Depending on the problem information will depend on what sort of hypothesis test we conduct. Let's begin with step 1, stating our hypothesis. In this case, we'll assume that sigma, our population standard deviation, is known. Notice that regardless of the alternative hypothesis, the null hypothesis stays the same. That is, H naught colon mu equals to some hypothesized value. For our alternative hypothesis, it is almost identical. The only difference is the symbol that's between mu and mu naught. This is going to be based on the situation described in our problem. Mu naught, if you weren't sure, is the status quo value given in the problem. Again, notice the null hypothesis always has an equal sign. Now let's look at step 2. Again, we are examining the case where we know the population standard deviation. Step 2, we need to specify the model and check assumptions. Since we know the population standard deviation, we can use the normal distribution. Therefore, we are assuming the null hypothesis is true, such that our x bar follows the approximate normal distribution with mean mu naught and standard deviation sigma over the square root of n. We also need to assume we have a random sample. Step 3, we are going to want to calculate a test statistic and a p-value. The test statistic in this case will be z equal to x bar minus mu naught divided by sigma divided by the square root of n. Next, we will need to calculate our p-value. which is, remember, the probability of getting a test statistic as extreme or more extreme as the one we just calculated, assuming that our null hypothesis is true. Again, that means that we are assuming that the normal model is centered at our hypothesized mean, mu0. We will draw a picture, and then we can either use StatCrunch or the z-table to find the area and the approximate tails. Step 4, make our statistical decision and conclusion. Well, if our calculated p-value is less than or equal to alpha, we will reject the null hypothesis. And then we will follow up with the following conclusion. At the alpha level of significance, we do have sufficient evidence that the alternative hypothesis is true. We will need to modify this conclusion in order to put in the appropriate scenario. Context is key. On the opposite hand, if our p-value is greater than alpha, we do not reject the null hypothesis, and our conclusion will be, at the alpha level of significance, we do not have sufficient evidence to say that the alternative hypothesis is true. Notice, we reject or do not reject based on the null hypothesis. We conclude based on the alternative. Now let's take a look at our second situation when we have a hypothesis test for mu. In this case, let us do the same, in this case, let us assume that the population standard deviation is unknown. Our step 1 is going to be the exact same situation, meaning regardless of whether or not we are given the population standard deviation or not, our hypothesis will remain the same. Step 2, this is where it'll get different. Our step 2 is still to specify the model and check assumptions, but in this case, since we do not know the population standard deviation, we cannot use the normal distribution. So instead, we'll use the similar t-distribution with n-1 degrees of freedom. And again, we will assume a random sample from a normal distribution. Step 3, we are asked to calculate the test statistic and p-value. The test statistic will be very similar to your previous test statistic, only in this case it is t equals x bar minus mu0 divided by s instead of sigma divided by the square root of n. The probability of getting a test statistic as extreme or more extreme as the one we just calculated, assuming the null hypothesis is true, aka the p-value, is calculated similarly. We will also draw a picture, and then we can still use a StatCrunch or a t-table to find the area in the appropriate tails. Step 4. This is a step that's going to also be the exact same as when sigma is known. If our p-value is less than or equal to alpha, we reject the null hypothesis. If the p-value is greater than alpha, we do not reject the null hypothesis. At this point, let's take a look at some examples. A rental car fleet owner suspects the mean annual mileage of his cars is greater than the national average of 12,000 miles. He selects a random sample of n equal to 225 cars and calculates the sample mean to be x bar equal to 12,375 miles and the sample standard deviation to be s equal 2,415 miles. Let level of significance be alpha equals 0.05. Okay. So, first off, what is our appropriate population parameter? Well, in this case, we saw the word mean a lot, so that means it's going to be mu. Specifically, it will be the mean annual mileage for all of the owner's cars. Our null hypothesis will be mu equals 12,000. If you don't recall, The reason it's going to be 12,000 is that we were given that the national average is 12,000 miles. Our alternative hypothesis is going to be H1 colon mu greater than 12,000. If we scroll back up to the original problem, we were asked that, or rather we were told that the rental car fleet owner suspects the mean annual mileage of his cars is greater than the national average. This will imply our alternative hypothesis needs to be greater than. Okay, so that completes step 1. Let's take a look at step 2, where we need to calculate the test statistic and p-value. Since we do not know sigma, we need to use the t-distribution. So we will use t equal to x bar minus mu naught over s divided by the square root of n. Plugging in our appropriate values, we will get a t-value of 2.33. And since we are using the t-distribution, we need to calculate the degrees of freedom, which is n minus 1. Which in this case will be 224. Using StatCrunch, we can go to Stat, Calculators T, type in our degrees of freedom. For our example, we will have that x greater than or equal to our test statistic, hit compute or enter, and we will get a p-value of 0.0103. That means that 0.0103 is the probability of taking a sample of 225 rental cars and finding an average annual mileage of 12,375 or more when the average annual mileage really is 12,000. Now we can do our last step. Make a statistical decision. We must ask ourselves, is our p-value less than or equal to 0.05, or is it greater than or equal to 0.05? If we scroll up, we can remember that our p-value is 0.0103. Well, at this point, hopefully it should be obvious that our p-value is less than 0.05. So therefore, we should reject the null hypothesis. So this means, since we've rejected, we now can write our conclusion in the context of our problem. At the 0.05 level of significance, we do have sufficient evidence to conclude that the population mean annual mileage is greater than 12,000 miles. Remember, if we reject the null hypothesis, that means we do have sufficient evidence. If we fail to reject, that means we do not have sufficient evidence. Now, before we go on to example 2, I realize in this problem we did not address the assumptions. So at this time, let's scroll back up and review our assumptions for when we have sigma unknown. So first off, let us check. We don't know sigma, so therefore we couldn't use the normal distribution. We used the t-distribution, and in the problem it said we had a random sample. So therefore, although I didn't state it, all of our assumptions were correct. Let's move on to example 2. Okay, example 2. A drug company is concerned that its 500 milligram aspirin tablets may contain too much or too little aspirin. Suppose the company selects a random sample of n equal 100 tablets and finds that they have a mean weight of 501.5 milligrams and a standard deviation of S equals 7.0 milligrams. Let alpha equal 0.05. To begin, we need to state our hypothesis. Once again, the problem was talking about means. So obviously our population parameter will be mu. Specifically, it will be the mean weight of all aspirin tablets produced by this drug company. Our null hypothesis then will be H0 colon mu equals our hypothesized value. In this case, if we scroll back up, the company's stated average or stated amount is the 500 milligrams. So that's going to be our hypothesized value. Our alternative hypothesis then will be H1 colon mu something 500 milligrams. Now, if we scroll back up and look at the original problem, notice that the drug company was concerned that there may be too much or too little. This is a two-sided test because it can be both directions, greater than or less than. So it would be appropriate for our alternative hypothesis to be not equal to, which is, as we wrote, mu not equal to 500 milligrams. Now, the next step says to calculate the test statistic and p-value. Once again, this situation was similar to example 1. We were not given the population standard deviation, which means that we cannot use the normal distribution. We have to use the t-distribution, and the problem itself stated that we had a random sample. So we can go ahead, since we have our assumptions qualified, and calculate our test statistic of t equals x bar minus mu naught over s divided by the square root of n. Plugging in our information, we will get a t statistic of 2.14. And our degrees of freedom will be 99 because n minus 1 or 100 minus 1 equals 99. Now we can use StatCrunch to calculate our p-value, which, if you recall, our p-value in this case would be the probability of getting a sample mean as extreme or more extreme than 501.5, given that the true mean is 500. Now, as this is a two-tailed case, we have to examine the situation of it being both greater than and less than. In order to do that, under the t calculator, we would type in our degrees of freedom, with x being greater than or equal to our test statistic, hitting compute, getting that value, and then doing it again only with less than or equal to a negative version of our test statistic. So negative 2.114. Or sorry, negative 2.14. By adding up our two tails, which notice the area is going to be the same, and that will be consistent. So if you want to memorize that, you just have to calculate it once and multiply by 2, that's fine. And you will get a p-value of 0.034. Now that we've calculated our p-value, we can go ahead and make our statistical decision. Since our p-value of 0.034 is less than our alpha, equal to 0.05, we will, once again, reject the null hypothesis. This means at the 5% significance level, we do have sufficient evidence to say that the population mean amount of aspirin in the tablets is different than 500 milligrams. Let's take a look at a third example. A random sample of 50 homes sold in Denver in 2010 had a mean price of $231,000 and a standard deviation of 150,000. Can we conclude that the population mean price in 2010 is greater than 225,300? We wish to use the alpha equals 0.05 level of significance. To begin this problem, we need to state our hypothesis test. In this case, our population mean parameter mu will be the mean price of all homes sold in 2010. Our null hypothesis will be mu equals our hypothesized value. Let's scroll up and double check. Oops. Okay, everything looks good. So our null hypothesis will be H naught colon mu greater than 225,300. And our alternative hypothesis will be H1 colon mu greater than 225,300. If we scroll up, remember, we are asked to find, can we conclude that the population mean price in 2010 is greater than 225,300? Now, if we recall, in this case, just like in our previous two examples, we were not given the population standard deviation. We were given the sample standard deviation of the 50 homes. Also, we were told that this was a random sample, so therefore we have to use the t-distribution. So let's go ahead and calculate our test statistic and our p-value. Our test statistic will be t equals x bar minus mu naught divided by s divided by the square root of n. By plugging in the appropriate information, we will get a t-value of 0.27 and a degrees of freedom of 49. Now we can go ahead and calculate our p-value. Now, in this case, our p-value is the probability of getting a mean as extreme or more extreme than 2031, or sorry, wow, this is twice now I've done that. 231,000, given that the true mean is 225,300. Our alternative hypothesis, if you recall, is mu greater than 225,300. This means that it is a one-tailed test, and we want to have the more extreme is greater than what we currently observed. So using StatCrunch and our t-calculator, we will plug in our degrees of freedom greater than our calculated test statistic of 0.27. We will then hit compute and get our p-value of 0.394. Now we can move on to our last step, which is to state our statistical decision and make our conclusion. In this case, our p-value of 0.394 is greater than our alpha value of 0.05, so therefore we will not reject the null hypothesis. This means our conclusion will be, at the 5% significance level, we do not have sufficient evidence to say that the mean price of all homes sold in 2010 is greater than 225,300. All right, now let's take a minute to examine our third example a little more. The following is a box plot of our sample data. Should we assume the population of prices is normally distributed? Well, if we examine this, what do you think? Is our inferences still valid? Sorry, scrolled up to the summary. In my opinion, yes, these are what I would be considering outliers, and this is approximately symmetric with 50% of our data to the left and the right. It's not perfect, but it is approximate, which is what we are hoping for. Approximately normal. Okay, so this brings us to the end of our lecture video. Let's just do a quick summary of everything we've done. First, we learned how to perform a hypothesis test for the population mean mu to determine if we have evidence to conclude that mu is greater than, less than, or different from a specified value. We learned that when sigma is known, the test statistic follows a normal distribution, and when sigma is unknown, the test statistic follows a t-distribution with n-1 degrees of freedom. That's it for now. Have a good night and email me if you have any questions.